Whatever, I don't know if we have class on Thursday or Friday next week, but that's when it will be. Okay, it won't be Friday, it'll be Thursday. I think your test will be Thursday of next week. Now, we're still, yes, any cereal that you would eat. Don't read 501 or something. Okay, if you like 501, bring it, but I don't think our kindergartners in the homeless shelter are going to want 501. That's up to you. Okay. So start planning accordingly. We're going to finish up the unit right now, and then we're going to start reviewing. I gave you the practice tests. We'll probably get to those today. So we're on 4.8. We're going to draw a picture, write an equation, solve it, round to the nearest hundred. This is review. I'm actually not sure why it shows up again in this section, because we already did some problems like this. We have a bird on the top of a tree. So here's the tree, here's the bird in the top of a tree. There's a point on the ground 100 feet from the base of the tree. So does it make sense to you that this is where the 100 is? This is the ground, the point on the ground, 100 feet from the base of the tree. The bird is 18 feet above the ground, and we are finding the angle of elevation. So do you remember doing these before?
Yep.
And we talked about always the angle of elevation or depression is going to go here, right? Always, it's going to go right there. So once we get everything into the picture, then we have to write an equation. And the equation is either going to be a sine equation, a cosine equation, or a tangent equation. So tell me, given this scenario, sine, cosine, or tangent?
Tangent.
Tangent.
Yeah. You guys, isn't this the hypotenuse?
Yeah.
Is it labeled?
No.
No. So the hypotenuse is out. Any function with hypotenuse is out. So what's the only one that doesn't use hypotenuse? Tangent. Opposite, adjacent. This is your angle, remember. This is your angle right here. So the tangent of the angle, remember, the angle is always hooked to the tangent. So it's tan 45 degrees, tan 96 degrees, tan whatever, right? Equals opposite side over adjacent side. Now we'll see who was paying attention back in the day. How do I find X? There's only one way to do it. One way. Samaya?
Some with multiplication.
Actually, no.
Or not.
Sometimes I multiply. Sometimes I multiply, but not this time. When I am solving for an angle, Allie?
Isn't it tan -1?
Yes, I have to use my second tangent button. We talked about this. Let's talk about it again. When we are solving for an angle, yep, oh yeah, these are, for it's going to be all calculated. When we're solving for an angle, we always use our second button. Okay? So let's make sure we're in degrees. And then second tangent, 18 divided by 100. How big's your angle?
I got 10 points.
I think it says 100, so we'll say 10.20.
10.20.
For the 100. Guys, it's warm in here today, so we need to take our jackets off if we still have them on. Okay? All right, let's look at question B. Find the distance from a worm on the ground, here's the worm, to a bird in the top of a tree if the bird's angle of depression is 24 degrees and the tree is 19 feet tall. find the distance from a worm to a bird. So somewhere I have to put the X. Where's the X gonna go? Distance from worm to bird. Isn't X gonna be the hypotenuse, you guys? It's like if the bird was gonna fly down to get the worm, how far would he have to fly? This is how he'd fly to get the worm. All right, so we're gonna write an equation now. What's that equation going to be? Sine, cosine, or tangent? Definitely gonna be a sine equation because we have opposite and hypotenuse. So sine 24, please remember the angle goes with the sign. Never put the angle in a fraction. The angle goes with the sign. So sine 24 equals 19 over x. Now, Samaya, I gotta multiply to get rid of that fraction. So I'm gonna bring the x over here. And then I have to divide by sine 24 because my job is to find x, right? So I need to get x by itself, just like I do in every regular equation in the whole wide world.
46.71.
Is he right? I didn't even type it in. 19 divided by sine 24. Yep, 46.71, and that would be feet. Too many examples in these notes because we did a whole bunch before. Remember the seagull on the cliff or something? We had a whole bunch of them. All right, one more though. How tall is a flagpole that casts a 23-foot shadow when the angle of elevation of the sun is 32 degrees? All right, let's try it. Draw it. Draw it, label it, compare it with your neighbor. Are Colleen and Giovanni on retreat?
Yes.
Oh, yeah, they sure are. All right, would you look up here for a second and see if this picture looks like yours? Now, did anybody put the X over here? Or put the 23 over here?
I put the 23.
Okay, now let's talk about that. The shadow is 23 feet long, okay? That's what it says. So pretend I'm standing outside. Where is my shadow? On the ground. Isn't that where your shadow is? Your shadow's not up here, right? The shadow's on the ground. So you want to make sure that you put your 23 down there on the ground. Is everybody okay with my picture now?
Yep.
Makes sense, right? We're going to think before we write down our numbers. Okay. So what function, now that we have the right picture, what function do we think we've got?
Sine. No.
Yeah.
Sorry, tangent.
Tangent.
Tangent?
Tangent.
Is opposite over adjacent.
Opposite adjacent. So tangent 32, always, always, always angle is hooked to tangent. So tangent 32 equals opposite over adjacent. So we're going to multiply like Smile likes to do. And in this case, after we multiply, we're done, right? Because we have x by itself. So what'd you get for that one?
14.37.
14.37 feet. Is that okay? All right, number 2, this is more practice with our navigation. Number 2 is just drawing a picture. So you're not going to need a calculator or do any equations or anything. You're just drawing a picture. But it's navigation. So we're starting with the framework, north, south, east, west, right? We're starting with our compass. And on the compass, 0, 90, 180, 270. Guys, we gotta keep that straight. I know it's tricky, but that's how it is when we're talking about the compass. And when you read problem A and it says, draw the path of a ship, you understand that's a compass problem, right? Because ships have directions. All right, so it sails for 4 hours on a course of 125 degrees. Okay, so where's 125? Wouldn't it be between 90 and 180? So I'm gonna go ahead and draw 125. This is 125 degrees. So now my ship is right here. Now I'm gonna read the whole problem. It sails for 4 hours on a course of 125 and then changes to a course of 195 for 1 more hour. The ship is traveling at a constant speed of 10 knots. Now, have you heard that word before, knots, in terms of like
Nautical
speed?
miles.
Yeah, it's nautical miles per hour. So when somebody says knots, it's miles per hour. Only they're nautical miles, which are slightly longer than statute miles, yeah. Okay, and that's because, in case you wonder, let me kind of explain that to you. It's because, like, when I drive to school, if I look at the earth, and here is my house, and here is Cathedral, that's pretty much a straight line, right? But if I'm going to England, here's my house, and here's England, I'm not flying in a straight line, I'm flying on a curve. That's called a nautical mile. I mean, the unit we use for that is nautical miles, and so they're slightly more than regular miles, which are called statute miles. I think it's like, statute miles are 5,280,
Yep.
and these things are like 6,020. What are they?
I don't know.
They're slightly more than that. They're more than that. Okay, but you don't care about that. That's not what's important. You need to remember that a knot is like a miles per hour. Okay, it's nautical miles, but it's like a miles per hour. So why I'm saying that is, you need to label this with a length. So remember that first part of his journey, he went for 4 hours, and he's traveling 10 miles per hour. So how long is this pink thing? 40. 40 nautical miles.
How is that for you? Oh.
Distance equals rate times time.
Oh,
4
okay, so
hours at 10 miles an hour. All right. So we label 2 things. We label his course, and we label how far he goes on that leg of the journey. All right, now he's going to make a turn, so I'm going to go ahead and set another compass up. I just put a little in there, but you can make it as big as you want. And now he's going, for the second leg of his journey, he's going on a course of 195. So keep in mind that This is 0, 90, 180. So where's 195?
Just a little past.
Just a
180.
little past 180? Wouldn't this be 195 right here? Now I'm gonna make that purple thing pretty short, because why? That leg of the journey, he only went for 1 hour, so it's only 10 long. And now he's right here. So that's the picture you have to be able to draw. So who has a question about that? Jacob?
Just in a sense of direction. So are nautical miles more accurate than regular miles, would you say?
Yep.
They are.
But they actually are, but we have to keep in mind that when we talk about driving the distances that we drive, it's pretty much a straight line anyway.
Okay.
But yeah, when great distances are involved, they have to take into account the curvature of the earth, so that's why they use nautical miles. We don't use it, like our cars don't have nautical miles on them, because we don't go great distances in our cars compared to the whole earth.
Yeah.
Okay. All right, so any question about that? First leg I did in pink, second leg I did in purple. Everybody clear on that? All right, one more. Draw the path of an airplane. All right, so I'm gonna set up my compass. Here's an airplane. And he is flying on what course? 50 degrees. No, his speed is 250 for 3 hours, but his course is 50 degrees. So his first leg of his journey is going to be like right here. Would you agree with that? And now he's here. How long is that pink line I just drew?
750.
750 nautical miles. So knots is a speed, so let's not say knots on that, let's say nautical miles. So 250 miles an hour for 3 hours would be 750. Does that make sense to everybody? So this is 750 nautical miles. That's how far he flew. So now he's right here. Okay, what's he gonna do? Well, he's gonna change direction. Set up another compass here. And now he's gonna fly on a course of 350. Where's 350? Almost all the way around, right? So wouldn't 350 be like right here? So here's 350. And that I can't quite, I would like to make that a little bit longer, but I'm out of room. Why do I want to make it a little bit longer?
Because it's almost as long as 7.
Yeah, it's 300 knots for 2 hours. So if you have room on your paper, make that a little bit longer, because this is 600 nautical miles. And that's where he is now. Yep, Samaya? Yes. All right, now, I've attached some extra practice stuff to your notes. Did you notice that? So what I'm going to do right now is, so I just finished my notes. Here's the end of my notes. I want you to turn the next page, and then the next page. So you should see a problem if you do that. On the back, it's number 11. It has a star next to it, and it talks about the height of a flagpole. So we ended our notes. flip the first page, flip the second page, and it's on the back of that second page. And the reason I'm gonna do this is because next time we meet, which is what, Friday? We are going to have a one problem quiz, and it's gonna be a bird looking at a worm, or a seagull looking at a fish, or a height of a flagpole, or, you know, one of those word problems where you have to draw the picture, write an equation, and solve it. Okay, it'll be one problem, and we're practicing it right now. Got it? So, let's do that flagpole problem, number 11. Here's the flagpole standing on the ground. Find the height of the flagpole. Where do we put the 27? Read it carefully. Where's the 27 go? Right here. And the angle always goes right here, right? Remember, in a couple days, you gotta do one of these all by yourself. Okay? All right, so here we go. What do we got? Equation wise. Cosine?
Tangent.
Well, I've heard all three. I've heard cosine, sine, and tangent. It is one of those.
Tangent.
I might have put mine down.
Tangent.
It's gotta be tangent. Okay, so I want everybody to look at your picture. You have the X here and the 27 here. This is your angle. X is opposite. 27 is adjacent. That has to be tangent. What's the equation then? Tangent 39 equals X over 27. So X equals 27 tangent 39. 27 tangent
21.86.
21.86 feet. You got it? All right, I want you to turn the next page. And on the front of the next page is another number 11. And this one is a bird. Everybody find it? The bird? Turn, flip one page and it's right there. All right, try that one on your own or with your teammate. And then I want somebody to come up and put it on the board for us.
Would that be the symbol? It's flying down.
Okay, so do I have a volunteer, a group of volunteers to come up and draw a picture for us? Okay, Jacob?
Yeah.
We're trying to focus here, guys. We're gonna have a little one problem quiz, and this is what it's gonna be on. It's gonna be words. You're gonna have to read. All right, step aside for a quick second. Take a look at his picture. How many of you have that picture? I hope you all have that picture because that's the right picture. Okay? Do we understand why X is the hypotenuse? How far is bird from worm? Perfect. Okay, now he's gonna write his equation. Then he's gonna solve it for us.
Everyone can see it.
Okay, step aside, let's check his equation.
Yep.
How many of you have that equation right there? I hope you all do, because he's right. That's a sine problem, opposite over hypotenuse. And I'd like to see the work that
Oh,
goes
okay.
with this. So what did you do there? No, that's right. X equals 18 divided by 728. That was directly
Yeah,
right.
well, okay. I thought I skipped a step.
That's, and that we, what did that equal? He got 38.34. 38.34 feet. Do you feel okay about that problem?
Yep.
All right, we have one more to do, and that would be in the 4A homework. You want to just go ahead and do this?
Sure.
All right, number one. Now, one is not on your quiz. Your quiz is going to be like either 2 or 3, okay? That's what your quiz next time is going to look like, 2 or 3. But one is on the test, so here we go. Draw the path of a plane that flies on a course. So I'm going to start by setting up my compass. Where is 100 going to be? 100 degrees.
Like right.
Right under 90, right? So you're gonna now you're like this, and you're gonna make that 100 degrees. Now, how long is that pink line I just drew? You should be able to figure that out.
600.
600 nautical miles, yep. So now my airplane is sitting right here. And what's he gonna do? Now he's on a course of 195. We already had that one today. Isn't 195 like just past 180 a little bit? So I labeled this 195. And if I want full credit, this is what I'm writing down on my paper. And how long is the purple one? 300 nautical miles. And now he's here. And he's done. Now I'm not going to get out a ruler and measure, but should the purple one be shorter than the pink one? Yes, so make sure it is. You don't have to use colors, but make sure this one's shorter than that one because he went less time. All right, number 2, this could be on the quiz. One problem quiz. It could look just like this. A 16-foot pole. Don't we always have triangles that look like this when we do these? They always look like this. So here's the 16-foot pole. Where's that shadow go? On the ground. Shadows are on the ground. Find the angle of elevation of the sun. Our angle always goes right there. Now I need an equation.
Tangent x equals 16 over 23.
She always says tan x equals 16 over 23. What do the rest of you think? Eddie's giving me a thumbs up back there. Why did we pick tangent?
There's no hypotenuse.
Because this is opposite and adjacent. So, katoa. Uh-oh. Be careful. We do not want to be multiplying in this one. Please don't. It's not going to help you to multiply by 23. What do you have to do if your variable is the angle?
Second.
You gotta use your second button. So second tangent, 16 over 23. Somebody's gonna have to do that on the quiz, okay guys? So you all have to know that when we are solving for an angle, it's second tangent. So second tangent, 16 divided by 23, 34.82 degrees. Actually, I'm not sure how I'm rounding here. It doesn't say, so we'll say 100 because that's what's on the other sheet. All right, try 3. See if you can draw a picture of 3. Let's go check here and make sure we got the right picture. How tall is a tree? A squirrel at the very top spots an acorn 34 feet from him.
Hypotenuse.
Hypotenuse, perfect. Remember, we read every word and then do what it says. So 34 feet from him. And the angle is 2810. Oh, there's an interesting twist. You know how to deal with it. We're not worried about it. We know how to do that. So picture satisfactory.
Yep.
Function, sine, cosine, or tangent. Need an
Sine.
equation.
Sine.
Sine,
28
degrees, 10 minutes.
Equals x over 34.
Equals x over 34. Everybody okay with the equation?
Yep, we're good.
And then we're going to multiply by 34. Let's refresh our memories how we type this in. 34 sine 28 second angle degrees 10 second angle minutes 16.05. Anybody else get that? Just take a minute, make sure you got that. answer okay? We all right with 16.05? Eddie, we okay with 16.05? All right, two more. These are different. These are kind of like review problems. But according to yesterday's quizzes, some of us need this review. Cosine 7 pi over 6. What is the first thing that you think of when you see cosine 7 pi over 6? Pi is 180, so 7 pi's divided by 6 is going to be 210 degrees. That is not the answer. I need to find the cosine of that. So I need to draw a picture of 210 degrees. Then make a triangle and find adjacent over hypotenuse.
Quadrant 3.
Now, here's where you gotta switch gears. This is not a compass. In regular math, 0 is here. 90, 180, 270. I know that's different than the compass. It's life in the fast lane. We just have to deal with it. 210 then, somebody said, would be all the way around to here. In between 180 and 270 is 210. Does that make sense to you? So I pop my perpendicular up to make my right triangle. And then I gotta find that angle right there. So this finger is 210. This finger is 180. So what's between my fingers?
30.
30. Don't be looking at 90 or 270 or anything else. You're looking at 180 and 210. That's what's making this angle. Okay, what do I know then? If that's 30, I know this is, what's it, 30, 60, 90. So this is 1, 2, root 3.
Negative.
And these two are both negative because we're in quadrant 3. So I draw my picture, now I'm ready to find the cosine. So the cosine is adjacent over hypotenuse. So the answer is negative root 3 over 2. Everybody okay with that? All right, last one, sine 3 pi over 2. So first thing we do is figure out what 3 pi over 2 is, just like we did over there. And that actually is 270, which kind of changes the way I go now. Because what about 270?
It's on an axis.
It's on an axis. This is 270. And if it's on an axis, I'm not going to be making a triangle. I'm going to be using my circle. And you can label the whole thing if you want, but this is really the only point you care about in this problem. Right, because it's the 270 point. And what would that point be?
0, -1.
0, -1. Beautiful. So the x is 0, the y is -1, and r is 1. Now I want sine.
Negative y over
So I
r.
have to remember sine is y over r. And y over r would be -1 over 1, which is -1. Okay? I'm gonna stop there, and everybody here, we did all of it, right? So everybody who's present today is gonna get credit for that homework. Don't turn it in, please. I'm gonna stop. If you